All right, hi everybody. I'm here to talk to you about a project which has the code name Tide Revert. It's a little bit cryptic, so I'll just jump into there quickly and talk about a red tide. I'm sure you're all familiar with this. It's basically just an out-of-control algae bloom that's kind of dangerous. But what exactly does that have to do with a revert, like an ocean tide and a revert? Well, just over a decade ago, I was the founding CTO of a digital signage and company in Africa, and we had thousands of screens deployed all over, predominantly in South Africa. And then words, which is still the longest four-letter word I've ever known, became a very common day occurrence because I'm not sure if you know what load shedding is, but it's basically when the power company can't provide enough power, so they randomly, semi on a schedule, start switching off power in different areas. So if you're the person on call and you're staring at your dashboard, you start seeing this, and then this, and then this, and then, yeah, you get the point. And this was basically unpopularly named the red tide. Once it started, you knew that it was just going to be not a great day. All right, a revert, I think all of us are pretty familiar with reverts, good old SVN revert. It usually starts with one of our familiar actors pinging us, somebody jumping on online, having a look and starting to investigate to figure out what's going on. You know, is it a request-based issue? Should we block it? You know, is it a bug? Should we patch it? Or maybe it was just a recent change in production that had an unexpected effect, and we should just revert that, or roll back, as some people call that. And that's pretty much what we're going to be talking about today. All right, rapid iteration. I work for a company called Automattic. We're predominantly a WordPress and WordPress adjacent products. We have a few others as well in the suite. But this talk is predominantly focused on WordPress.com, which is the largest multi-site WordPress installation in the multiverse. And actually, we iterate a lot, almost 1,000 deployments a week. This is actually probably live on our website, updates all the time. So we're deploying a lot, right? And there are quite a few challenges when you're doing rapid iteration to that scale. I mean, blue-green deploys just aren't going to scale. You can't possibly subdivide to that degree. Staged deploys don't work for us because we don't run in the cloud, we run on-prem, so we don't have everything neatly, blocked out in different regions for us to do. We have the common mono repo issues, which everybody's aware of, with issues between different seemingly unrelated features. And having something like that where you're iterating as often as that, you need to be able to roll back rapidly. And of course, there's the possibility that you'll trigger a red tide. Okay, so we have these issues, red tides can happen, we're iterating a lot. What can we do to reduce the toil and stress of dealing with that? Because as you can imagine, especially if you're a junior engineer, you're on call for the first time, something happens, boom, red tide, stress. So I'm going to a bit of a segue here. Automattic is a fully distributed remote company, so we have engineers all over the world, in fact, in 92 countries. And what that means is that at least twice a year, we get together somewhere in the world, we pick a city, and we all fly there and hang out together and collaborate. And this year, we actually ended up going to Athens. And while we're there, we do meetup projects. Okay, this is a good thing, brings everybody together. We like to iterate on existing features or work on something the team's interested in. Or one of our favorites, obviously, is to do something that has a high impact on toil reduction, or some fancy user-facing feature that's going to win us brownie points when we get back from the meetup. So how does this all sort of relate? Well, Dr. Fix-It is an application that we put in place that helps engineers deal with red tides and reverting. It's very simple. It has an Elk stack backend collecting from production. Then we have a WordPress-backed PHP service. This does some very simple lookups, and then a Slack app to communicate with the outside world. So on the right-hand side, or your whatever side, Dr. Fix-It has found that there's 50 of a particular incident that's causing fatals in production, and it's gone and grabbed the last 3 commits that it thinks has, it's actually, there's no thinking, it just grabs the last 3 commits within a time range and says, these are possible commits that you should look at. Now, if you're on call and you've got a red tide happening, this can be a little bit daunting. You've got to quickly open and check the cause, check the issue, figure out what's happening. That can be a very stressful thing to do, and it can be quite overwhelming. In this particular case, we have 3 possible causes. There could be more, sometimes less. But so Dr. Fix-It's put in place for that. So we decided that we would iterate on this. It can have quite a good benefit for toil reduction. So we had this big plan, right? AI is the big thing. Let's use AI to determine whether a particular commit caused a stack trace, right? Seems pretty cool. We'll then be able to filter the list which means there'll be less on-call noise. It'll be much more actionable for the engineer on call. And then we'll output a command that's very easy for them to do a revert. So we'll reduce the time as well, so it's not fiddly and it's quite simple. And then as a stretch goal, potentially if we get it down to a single commit that caused that issue, then potentially we'll get the AI to execute that. Right? Seems pretty cool. All right, so how did we go about augmenting the service to do that? All right, that's a plan. Pretty simple. Gather some tests, create a zero-shot prompt. We'll use this on our internally hosted LLMs because we didn't want our code to leave the network boundary. So yeah, we got together. We were busy putting this all together. Now at the meetup, obviously, we have dinners together and whatnot. So we quickly crafted a little proof of concept in our array cluster and got a tiny test set together. And we ran a quick test before dinner. All right, 2 out of 3. LLMs were able to determine 2 out of 3 times, I know it's a tiny test set, I did say so, that the particular commit caused the stack trace. But there was one, and they all agreed on the one that didn't cause it. So this became a topic for conversation at dinner, and I convinced them that we needed to double check that we had actually had the correct test data. Turns out the LLMs were correct. And we had to fix the test data, so they were getting 100%. Okay, now we're really wind in the sails. We think we're definitely heading for a popular release here when we get back. So we start iterating a bit more, doing zero-shot prompt, bigger LLMs. We actually deploy a service with an AI agent. We cherry pick 14, which is quite representative of the type of errors we get in production. And we do negative cases by just mismatching stack traces and commits to see if the LLMs can see if the negative tests. And our best run was 26 out of 28. Okay, now we're talking about a lot of excitement. Okay, here we have a situation that surely all we need to do is add some agentic reasoning, maybe some tool calling, and we'll be ready to go. And I mean, we were flying high. There was visions of finally being able to get back on a stool with a sword. Like, this was going to be a good thing. And this was the point, in fact, that I submitted this talk for this conference. Obviously, we all went home on our flights, all feeling pretty chuffed about it. And a couple of months later, once we'd gotten rid of our priorities, we started picking up on this and having a look. So how about those 2 test cases? What did we do? Okay, so we knew we needed some sort of agent here. So, this typical Sutton and Bartow reinforcement learning agent, it observes the environment, it evaluates, performs an action, gets some sort of reward from the environment, and then it loops until the end of a game or an episode, or it carries on forever if you're doing a continuous control agent. So how does that map to an LLM? Okay, well, an observation is a prompt, and evaluation is reasoning. Performing an action is a tool that LLMs have, which I'm sure you've all interacted with, the function calling that's available today in a lot of the OpenAI and friends. Reward depends on the cognitive architecture that you choose for your agent, and then we'll basically loop until we get a final answer. Okay, seems pretty cool. Now, whenever you're talking reasoning and tools in AI, the default to go-to is React. Here you have a reasoning loop mixed with actions, and in fact, this is exactly how all of the AI companies are implementing tool calling. So we started building our own React agent, started adding tools to do different things, right? We'll fetch different things, we'll do get blame. These were all iterated as we were looking at our test cases, like what is the agent missing? Looking at a trace. All right, it needs to be able to find the function definition and that sort of thing. And then we built up and built up. We even added a capability from the reflection paper, which allows the agent to reflect over its thought processes. And all of these things were slowly helping the agent get more and more capable of achieving its goal. We looked at chain of thought, and which is the sort of go-to beginning point of doing any sort of agent control. And there are many of these to choose from. Many to test, many to iterate on. We also tried tons of open source and open weight LLMs, right? All the ones that have scored really well on code benchmarks for reasoning. Lots of different iterations here. So about those 2 test cases. Well, I have to say that there's one thing about agentic reasoning is that they can get it perfect. You can have a look at a reasoning trace, and it'll be the most inspiring thing that you've seen the entire month. And then you'll run the same thing again, not so inspiring. It'll over-obsess over a particular tool. It'll just continue going and sort of runs out of context window. So we're still wrestling with getting those final 2 consistently. But why is that? All right, let's take a look at LLM reasoning. We all know they tokenize text, and then it's simply predicting the next one based on a probability distribution, which is tweakable with some parameters, which we won't go into today. It's very well known that when you're training an LLM, it gets to a certain point that's called grokking, right? It was trained in whatever, let's say it's doing maths in English, and suddenly it can do maths problems in Persian. You know, and surely that's reasoning. Well, it turns out it's not really, and it's got a lot of, with this kind of two camps here. You've got the forest of jumbled thoughts, where people put out papers to try and mock what people are calling reasoning. And the reason for that is they're just pattern matching systems, right? Really advanced pattern matching systems that have seen bigger patterns, but their skills are crystallized. They don't learn anything after the point of being trained. They have no system to thinking. You know, they actually aren't capable of reasoning because there's no loop unless you introduce it. So LLM reasoning is not really a thing. Agentic reasoning, however, is a whole different thing. This is the chain of thoughts that I was showing earlier. Here you also look at cognitive architectures that you implement, like the one on the right, which is the Koala thing. You have the modulo framework. You have NeoLAF, which is neurosymbolic, and all of these things are active areas of research. But the bottom line is it's currently not solved. You cannot just take some sort of a thing and implement that reasoning, and your agent will be able to call tools and infallibly get to the end result. It's just currently not solved. So where are we now? Okay, we've gotten to a point where we have created a domain-specific cognitive model, so drawing from Koala and friends, and creating something that can solve the problems. And the reason for that is when you're creating these agents, because it is not a solved black box thing, is that you have to add code execution to shepherd and shoehorn your AI in the way to make it sure it's compliant and goes in the direction that you want. We've had to implement control points to make sure that you don't let the agent just continually have thoughts without stopping and reflecting, or actually getting to a point and limiting and saying, can you summarize and see where you're going and pick a new direction? You need to limit the AI to have a certain number of step limits and plan limits to make sure that it doesn't create this elaborate plan and then get lost halfway because it's forgotten what it's actually supposed to be doing. But we've got all of these things in place, and we've also implemented agent-specific frugal use of tools, because as I said before, they might use the wrong tool, or very often they obsess over the wrong tool. So it's good to keep the number of tools that you implement down to a minimum. And we've ended up with this sort of hodgepodge, which could loosely be called a reflective chain react agent. All right, once we had that, we also moved to the next level, which is a multi-agent graph. And this is sort of where we're at the moment. This multi-agent graph basically replicates an on-call environment. We have task-specific agents, so 2 SREs, one developer with its reflective chain react agent type. We have an SRE manager who is an agent as a judge and basically takes the input from the 2 SREs and the developer and then makes a call as to whether that commit caused the stack trace. Above that, we have an incident manager whose job is literally to take the answer from the SRE manager, format it so we get a nice clean JSON output. So that's currently where we are at the moment. And for anybody who's wanting to implement something like this, there are a few learnings which I think I'd like to go over in case you want to do that. Step 1 is you have to embrace non-determinism. This is literally, I would say, the only blocker for anyone in this room, if you're looking at doing it or if you haven't already. We are so used to having functions where you put in A, you get out B, wrap it in a unit test, it's going to be like that forevermore. It just simply does not work like that. We're dealing with probability distributions. They've got the as they called stochastic parrots. You really have to embrace developing in a non-deterministic environment to be able to move past the initial proof of concept and start creating your own domain-specific cognition model to achieve your particular end result. Definitely only pick a single capable LLM. Having too many LLMs is a just basically you end up with LLM sprawl. You have no idea which one to use next because what about this, what about this? You need to really intimately learn the ins and outs of your LLM that you choose. If there's a small little change in a prompt, you're aware of what the output change is going to be. This will drastically simplify your development. You should also pick a single feature, in fact, just a runbook. If it's a simple step-by-step runbook, take the runbook and split it up into a multi-agent thing, look at each individual step in that, and then your process, and create a task-specific agent for it, limiting the number of tools that you give it so that it can attain its goal and only its goal, and then pass it on to the next, and you have another LLM, or another agent, sorry, that can do its task really well. And that way you can very easily control it, and you can code in those flows to ensure that you get to the end result. Well, which is what I was saying, yeah, specialized. All right, the other thing that's critical is it is an iterative process. But by iterative, I mean, if you change one little word in a prompt, it changes the output completely. So you have to version your prompts, you have to make small incremental changes and then run your tests. Just make small changes and run your tests. It's a very long process, but extremely rewarding as long as you stick to this, because there's nothing worse than changing a few sentences in your prompt, running again, and everything's upside down. Qualitative evaluation, this is really important because you can create your reasoning traces, and then you can use LLMs to actually help you evaluate the end result. So you can set something up that can run as a test harness where you've got your end results talking to LLMs, and the LLMs are scoring and saving things accordingly. So afterwards, it's much easier for you to go back and actually see what happened and work on improvements from there. All right. What's the future state look like? Well, for Dr. Fix-It, we're going to continue iterating on reasoning until we get to that point where it's a little bit more, this sort of passes more of its tests more reliably. We're going to look at implementing the memory from the Koala paper, which is emulating the way humans store the learnings that we have to give it the ability of not having crystallized skill. And potentially we'll even move to a point where, since we don't really want to limit the number of commits that we check against the stack trace, we'll just give it the stack trace and it can use git blame style function calls to track down exactly which commit caused it, which is obviously a stretch goal, but that's where we should go. The actual industry itself, whether we need something like a Kalman filter for our agentic reasoning, or we end up with some tree of swarming agents with some new search algorithm that helps us navigate how they're thinking so we can get the best output, or we finally get to stochastic determinism. I think it's very apparent to me that we are heading towards a future where we will be able to work more on the things that we want to and need to as agents are taking care of some of the more mundane things, and hopefully we spend more time looking at oceans like this. All right, that's all I have for today. Any questions?